Okay, so we talked about lambdas, we talked about default methods and method references, optional class. We talked about functional interfaces. The next part of the lecture is going to be about the streams, a stream API. This is another big area of change in Java 8 compared to the previous versions of Java. And the whole idea behind the stream API is collections are used very, very often and commonly in Java. Like I said, almost every single program that you write has to deal with some sort of a collection of objects, right? And normally, if you have to do something with that collection, it's always from outside. It's a procedural way of doing things. We write a loop, we loop through all the elements of the collection and do something with it. We filter them, we process them, you name it. You do something to those elements. Now, this is not always the most effective way of doing things. The functional way of doing things is instead of always looping through or iterating through all the elements of the collection and applying something from outside to it, the collection itself has intelligence. If you have a functional programming way of looking at things, is that you wrap your functionality inside a class, you create an object of it, you pass the functionality to the collection and say, okay, apply this to the whole thing. So that's the functional way of looking at things. And the other thing is, Java so far has been a procedural language. And by introducing streams, we're changing it to a declarative language. And what a declarative language does is that instead of you having to go through all the details, so for example, going through a loop, sorting elements, doing whatever you need to do to all these single elements, instead of doing that, you just declare what you need to do. And the details are taken care of by the programming language. An example of a declarative language is SQL. In SQL, you don't write any loops, or at least normally you don't. What you do is that select this or insert that or update, you write an updated statement. And all the elements that match a particular category are going to be updated by whatever value that you're passing in, right? So you don't see a loop, you just declare what needs to be done and the language takes care of it. So the stream API is an attempt in that direction. The other major change in the Java Collections API, I'm just going to mention it here, I'm not going to go into a lot of details, is some performance improvements for hash maps. Hash maps are used very, very extensively. The main advantage of hash maps is search. You can do a dictionary search on hash maps, and hash maps is the big O of 1 in terms of the order of magnitude of operations for searching and finding elements. So that's the main advantage of hash maps and why they're used especially in Java, and why they're so popular. So Java 8 has made some performance improvements. That's all we're going to say about that. Now, let's see how we use the streams and what the streams can be used for. Let's look at the simplest possible example. You have an array of integers, 1, 2, 3, 4, 5, 6, 7, 8, and then you change them. Here I'm converting them into a list, right? So we have an array, we convert it to a list, and what we need to do is to find the sum of all the elements inside this array. What is a normal way of doing it? You set an initial value of 0 to sum. You loop through all the elements of the list in this case, and then you just add them to sum, and at the end you can print the sum, right? Extremely simple idea, okay? How do we do this using streams? Using streams, what you do is this. You have a list, integers list. You convert your list into a stream, and then you reduce the list. And so what the reduce function does is that it reduces the collection into a single value. You're basically saying that I have a collection of items, apply this function to this list or collection, and then reduce it to only a single value, and then get that single value and return it back to me. So as you can see, this is a new way, a new paradigm of thinking. This is a new way of thinking about computer programs. Previously, in previous versions of Java, you always had loops, and then you loop through items and then you do something to it. This is a completely different and functional way of looking at computer programs. So we're going to see some more examples, but let's just look at the principles of the streams and then see how they are. And by the way, the interface list did not have a stream method in previous versions of Java. How was this added without breaking millions of lines of code? Using default methods, exactly. So this stream method is just a default method inside the stream, and then this is from the stream library. So the rest of it is brand new in the stream library.
Excuse me.
Yes.
The integer class has some method.
Yes, and okay. So the Java collection library has gone through a big overall change. And so, yeah, apparently it does. Yes, and then so the wrapper classes such as integer, double, etc.
Okay.
So Java has made a lot of changes. A lot of default methods have been added to different classes.
Sometimes we can do it using Lambda, using A, B as a parameter, and we can say A plus B.
Absolutely, you can do that too.
Okay.
Yeah. So these are just different ways of doing the same thing. Yes.
We can have employee as well.
You can. But you cannot sum employees. What would you do?
Yeah, employee, we should put a method in the employee class and call it.
Yeah, you can maybe, right, either you have a sum method inside employee class, or you can say here E1, comma, E2, and then the lambda, sign, and then on the other side you have, E1.getSalary plus E2.getSalary, something like that. Write the lambda expression. Yes.
I just thought, I don't know, it would be interesting to see can we say the internal implementation of the reduce method could basically just be them doing that accumulation in a loop?
Yes, the internal implementation of the reduce method is something like this. You have a collection of objects, and then the functionality of reduce is that grab any two elements, and by applying that function, reduce these two into one, and then apply the function between this one and this one, and reduce it to one, then apply it to this one and reduce it to one.
So just keep accumulating.
It may not be exactly that, but this is a simplified way of thinking that, how it's done. So you basically, reduce requires, it probably, let me see, what is the type of that lambda expression? I think it's either...
It has an initialization value, so you can accumulate each loop.
Right, it has initialization, yes, all of that. Yeah. But it's mainly a function. You pass a function, and that function, you pass two arguments, and you get one return value. See, you pass two arguments and return one value. Then between these two, you get one value. Between those two values, you get one value.
Can we pass the initial value to it? How we can pass the initial value?
I have to go back and check. I don't remember. But there is a way of doing that.
There is an override for the reduce method which get
overloaded, you mean?
Overload,
Yeah. So reduce method has been overloaded. So this is one version of it, which starts from 0, and there's a version of it that it starts from some initial value that you can actually enter here. Okay. So going back to streams, let's see what is a stream. You can think of a stream as a factory. A factory has a production line. Have you seen all these conveyor belts that go through the library, and eventually a product is built? On one end, you enter raw material, and then that raw material is processed. Maybe at some point, some damaged, goods are discarded, and then at the end, you get the finished product. So that's the idea of a stream, that you can think of it as like a factory line. Okay. Every stream has these three elements. It has a source. It has one or more intermediate operations, and there could be as many as you want to think of, and you have exactly one terminal operation. What are some of the examples? The source of a stream The most common source is a collection. But it can also be a file. It can also be an I/O stream. It can be some network feed. It can be some streaming video. And the very interesting point about the streams that I'm not going to go into very deeply today is that a stream can be made of an endless collection or a stream of elements. So you can have an endless stream, and you can still perform operations on it, and it would do fine. Although, don't call for each on an endless stream, because this is never going to come back. I mean, this is an infinite loop, basically. Because you have an infinite number of elements in an infinite stream, then for each is just going to block and keep whatever you're doing, printing, saving, deleting, whatever you're doing is never going to finish. So that is your source. Then your intermediate operations, you can filter, you can map, you can do these things. And your terminal operations, when you're done and when you have your finished product, then you can do something with that finished product. Print it, save it to database, get it as a list, return it as a list. All those operations can be done. Here are some more examples. For example, for intermediate operation, we have filter, map, peek. Peek is, let's say that, the production line, imagine it's inside a closed tube. And sometimes you want to, cut the loop and then have a look inside and say, okay, what is passing through? And then peek is exactly that. Every element that is passing through the whole process of a stream, you can look at it, have a peek, basically. And then terminal operations, these are just some examples. Stream, it has, many, many more methods, but one of them is for each, which basically is a loop. And just a word on for each. For each is something that we call an internal iterator. How many people know the difference between internal and external iterators? Has anybody taken ASD here? Okay, so the difference between internal and external iterator is that, again, in previous versions of Java, always you iterate externally, or normally you iterate externally. You get an iterator from the collection, and then you write a loop, maybe a while loop, a for each loop, some sort of loop, and then you loop through elements and you do something to those elements. For each is an internal iterator. It means that it's not going to give you the collection, it's not going to give you an iterator. What it does is that you give it something. You give it a function that is wrapped inside an object, and it applies it to every single element inside that collection, or in this case, a string. And then you can do other things like count, sum, average, minimum, maximum, and then collect is going to return the end result as a collection back to you. So you convert your collection into a stream, then you filter, then you map, then you do this, you do a whole bunch of processing. Then at the end, you collect all the elements back as a list, as a map, as a set, as some sort of collection. We have, and this is called a terminal operation, because after you do this, your stream is done. This is the end of your factory line. After you do that, your stream is useless. You cannot use it for anything else. You cannot reuse it. And sometimes we have terminal short circuit operations. These operations, they go through every single element inside the stream. These operations do not necessarily go through every element inside the stream. As the name implies, they're a short circuit. They go do whatever processing they need to do until they get to the result, and when they get to the result, they finish. They just end right there. They don't continue anymore. So if you have a collection of 1 million items, you convert that to a stream, and then you do a find first. Let's say you're looking for first name John, and you have 1 million people in person objects inside your collection. The very first John object that you find, which could be the very first object, or could be the last object, or could be some object in the middle of your list, you're done. You don't continue processing. You don't waste CPU time. You break out of the loop. Okay? So this is short circuit operations. Okay, I think I'm going to show you some examples, but I'm going to keep the examples for the end, and I just have a few more slides on a few more topics, and I'm going to show you a demo maybe at the end if time allows, or if you're still fresh enough to go through examples. Remember I talked about compact profiles, and I said if you want to run Java on a small footprint device such as a Raspberry Pi or You name it, Arduino. How many people have seen Arduino? Okay, so those are small devices, and they're small in size, and they're very cheap, and they're computers basically. You can think of them as computers that are very, very small. So you can use compact profiles. And the way compact profiles works is that currently in Java 8 we have these profiles. Compact 1 includes these Java class libraries. It includes a core, which is Java lang, security, serialization, zip, jar, logging, date and time, all the things that you see here in red. Okay? And if you don't need anything else, if you don't need it, if you don't have a database on your Arduino, you don't need JDBC, you don't need RMI. If you're not doing anything over the network or remote method invocation, you don't need RMI. So you can use just Compact 1. And Compact 2 is compact everything in Compact 1 plus JDBC, RMI, and XML JAX-B. And then you have Compact 3, which is again everything in Compact 2 plus more. And then you have the full standard edition API, which is the full JDK that we use. So that's the idea of compact profiles. Just thought I would mention it, just in case you ever do some embedded programming or programming for small devices. The very last topic that we're going to cover today, and it's just a few more slides and then we're done, is the new date and time API. In the older versions of Java, we had date, we had a class called date, we had a class called calendar, we had simple date and time, I can't remember what was it, for formatting date and time, and that was about it. There aren't a whole bunch of classes supporting date. And if you have ever done date manipulation, it's a big pain in the neck. It's not an easy thing to do. And if you have time zones, I worked for Bank of America, and we had servers in 3 time zones. We had servers on the East Coast, we had servers in Central, actually they were somewhere in Central Time, and we had servers on the West Coast. And the idea was that if a hurricane happened on the East Coast, and the data center in the East Coast was down, and an earthquake happened in San Francisco, and the San Francisco, the West Coast data center was down, Bank of America would still be able to service its 10 million logins a day and 500 million transactions a day. So if you have a high availability application like that, if you could work for Google, LinkedIn, Facebook, it's all like that. They have servers not just across time zones in a country, across the whole world, across all the time zones in the world. And then let's say one server sets the date to something and sends it to another server which is in a different time zone. All this time zone conversion is a nightmare. In 5 years between 2010 and 2015, I worked on 8 different projects for 4 different large banks, and every single one of them had production issues with date and time, and exactly with the issue of time zones. It's a complex issue because your database is in Texas, your front end, your Spring MVC that runs your Spring MVC and presentation layer is on the East Coast, and then other part of your server, your web services are running it on the West Coast, and these are just real examples of what is done in terms of enterprise Java. So that was just some motivation to simplify all of that. There's a process called JSR. I think it's called Java Java Specification Request. So Java is an open source community. Anybody, anybody, big companies, wherever you are, you can send a request to the Java community. Say, okay, here's an idea. Java is a great language, but is missing this feature. Can be added to the language. And JSR is a way of formalizing that request, and maybe adding it as a candidate for future releases of Java. And one of those Java specification requests, specifically number 310, was a brand new library of Java date and time classes, and that was actually implemented in Java 8 and was added to Java 8. And the whole idea behind it is, so for example, in Java we have the Gregorian calendar, but imagine Gregorian calendar, so how about India? We have, in India they have their own calendar, right? In a lot of Middle Eastern countries, we have the Hijri calendar. In Iran, which is my home country, we have a different kind of calendar, which is a specialization of the Hijri calendar. So, and then not only that, but then date and time formatting. Date and time formatting, the whole world follows ISO. United States follows a different standard. Okay? So, and then that is very confusing. All of that causes confusion. So, the whole purpose of this JSR is providing classes and utilities that are easy to use and follow international standards. So that's the new date and time API. So here are some of the design principles that are behind date and time, the new date and time API. The date and time API is clear, which means there's a clear relationship between name and form. If you call a method and that method says, let's say, minus, it's exactly doing that. It's exactly doing what you expect it to do. If you pass a null to a method, you get a null pointer exception. So everything is behaving what you expect it to behave. It's fluent, and fluent is the idea that your code reads like fluent English. You read it from left to right, and it's exactly, does what it says it does. And the other thing about fluent is that you see when you call a method on a date and time, so for example, you have a local date, okay, and here's how you do that. You create, and here's the other thing about these classes. You don't say new local date. They have private constructors, so you can't do that. You have to call the factory method on those classes to create objects. And what the other thing about them is that when you call a method on a date and time object, the method returns the same type of object. And what this does effectively is that you can chain methods. So after calling this method, you can say dot, call the next method, dot, call the next method, dot, call the next method. Okay? So this also is part of being fluent. So fluent is two things. First of all, it reads like plain English. The second thing is that you can chain methods. And that's a very, you remember the stream API? You say something dot stream, dot filter, dot map, dot reduce, dot, so that's also a fluent API. So this is an, underlying design principle that was implemented in Java 8. It's immutable. What immutable means is that once you create a date and time object, it cannot be changed later. Just like a string. A string class in Java is immutable. Once you create a string object, the value of that string can never be changed. If you want to make a change to it, effectively what happens is that you create a new string and the old one is going to be garbage collected. What is the advantage of being immutable? It means that these objects are thread safe. And it's very, very important because in today's world, almost every application is a web application. All web applications by nature are multi-threaded because you run a server and your server can be hit by millions of users at any instance of time. There could be 10. In the banks that I used to work for, I think we had about 2,000 threads. So we were expecting that 2,000 users simultaneously are using our system, right? So if you have 2,000 threads and you have all sorts of synchronization problems and race conditions and you name it, then the easiest way to prevent that is this being immutable. Helps a lot in that direction. And here's an example. So for example, you have a local date and its date of birth, and you see you create, and then the creation methods. Remember, one of them was now. Now creates an instance of now or today or whatever that instance of date and time is. But there is also the of method as a creation method that creates it very easily for you. 2012 May 14th. So this is the date object representing this instance of time. And then here, what you do is that you want to basically add 1 year to it and see, okay, 1 year from this date, what is the date? You just say plus years, And what this does is that it doesn't return the same object modified into a new date. Remember, because date is immutable, so you can't change it. What it does is that it instantiates a new date object that represents 1 year, well, this date plus 1 year. And then extensible. Extensibility is also important. It provides a lot of flexibility in terms of extending the language and so on. Okay, let's look at some of the simplest classes that are here, and I'm going to wrap up in just a few minutes. Two of the most useful ones are local date and local time. So local date doesn't include time; it's only date, right? It's basically a year, month, day representation. And the thing is, the toString method has been overridden, and the override of the toString method, what it does is that it prints in ISO format, 4-digit year, 2-digit month, 2-digit day. Okay, so now Java is not geared towards US customers only. This is following international standards. And how about time? Time does not include a date. It's only time, hours, minutes, seconds, nanoseconds. And if you call the toString method, you get hour, minute, second. That's what you would expect. You don't need any formatters. You don't need to call. You see, all of this had to be done manually in previous versions of Java. If you wanted to format a date and or time object, you would have to do a lot of manual operations. But here you just call the toString method. You just print it, and it's going to print the right object. So here are some more examples. Here we have local date time, which is a combination of date and time, as you can imagine. Again, remember, it was supposed to be clear API, right? You expect local date and time to be the local date and time. It is what it says. So this is how you create right now the date and time of right this minute. And this is getting the date for December 12, 2012. This is getting a date representing 150 days after epoch. And remember, epoch is January 1st, midnight of January 1st, 1970. That's just a reference in time. You could go forward or backward. If you want to go before, so go to 1969, you say minus 150 or minus 300, minus 400. You can do that too. And then you can say local time of 1718. This is the time that I took my, the train that I took home today. It was, the 5:18 p.m. Train. The local time representing 10:15, 30. So if you have a string, remember we said the toString does this and toString does that. So if you have that, and from a string you want to go back to the date and time objects, you use the parse method. And more examples. I don't need to go through all of them for you. I'm going to show you this and then wrap up. So these are the main classes inside the Java date and time API. As you can see, we have local date, local time, we have local date time, and then you have zone date time. Remember I said time zones? So if you have time zones, then it's better to use zone date and time, because it also has a zone ID and a zone offset and that sort of thing. And here's the a column that represents, okay, if you call the toString output, what is a sample output that you would get from each one of these classes? So for a local time would return something like that. A local date would return something like that. A zone date and time is going to return something like that. It's the date followed by time, followed by the time, the zone offset, which is how many hours, difference between Greenwich Mean Time and this particular time zone, and also the name of the zone. This is Asia, Tokyo. Okay. If you're interested to receive a copy of this presentation, you can email me. My email, I'm going to write it on the whiteboard for you at the end of the presentation. and I can send you a PDF copy of this presentation. We don't have time to do this. I did that for my class when I was teaching MPP. But this is a very, very nice overview of Java 8. This was the keynote talk at Java 1 conference. And I actually attended that. I was there when this was being recorded. And this is a very, very motivational piece of a talk that we can listen to. And then you can actually hear what I just said from experts such as Mark Reynolds is the chief architect of Java platform in Oracle. There is Brian Gitz speaks there, and Brian Gitz is the main genius and Java architect behind Java 8. So you can hear from interesting people like that. And that's the other thing about going to conferences. You get to meet very, very inspiring, extremely experienced software developers and computer scientists. And so, for example, I met Gosling in person. Gosling is the father of Java, the person who created Java. So you get to meet them in person and ask them questions and listen to their talks. And at the end, I have some links. If you want to know more about these areas of Java 8, you can follow the references. The only other thing that I want to do is just to spend maybe about 5 minutes. Can everyone stay for about 5 more minutes?
Yes.
Okay. So what we're going to do is to look at some examples. So, but before we go through the examples, any questions so far? Okay. So let's see some basics of the streams, right? Here what I have done is I have a utility called top cities, and what it does is that I have a CSV file. It's a comma delimited list of top 20 cities in the United States in terms of population. So it loads those cities, and it basically loads a list of city objects. And city, let's go inside it, see what it has. It has, name, state, population in 2012, population in a whole bunch of years, population change, and rank, in terms of population in the United States, okay? So we have that. So this is just a static method that returns a list of cities. And here's what I'm doing. What I'm doing is I plan to print the list of US top cities in terms of population high to low. And how can I do that? There are different ways of doing this. The simplest way of doing this is, well, first of all, we have a collection of items. Top cities is our collection. We convert it to a stream, then we sort it. To sort it, we need a comparator. We need to provide an implementation of the comparator object. And to do that, one way to do it is to use an anonymous inner class. And this is an anonymous inner class. What you do is that you say, okay, the type that you're implementing is called comparator. So this is the name of your interface, comparator of type city. So this interface has exactly one method, and you need to provide an implementation for that. And this is exactly what you're doing: C2 population minus C1 population, right? So this is that. And so this is an object of type comparator is created like that. You pass it to sort it, and it's going to sort it, and then you use the for each. Remember, this is so you have a source. From the source, you create a stream. From the stream, you have some intermediate operation. In this case, sorting is your intermediate operation. And then you call for each, and for each is going to print every single element in there. And then here we are using method referencing. So we call the println on the out object reference of system. So that's one way to do it. The other way to do it is which is a little bit simpler, is both for each and sorted, you can express the implementation of these two things as Lambda expressions. Now I have a question. Can somebody tell me what is the type of this Lambda expression? Java is a strictly typed language, except for people who have taken my MPP class. So Java is a strictly typed language. So everything has a type. Everything, absolutely everything has a type. If you define a variable, it has to have a type. It's, you say it's of type person, it's of type employee, it's of type integer, it's of type int, right? So what is the type of the argument that we are passing here? Comparator? This one is not comparator. City? It's not city. City is this. C is city. But then what is the type of the argument that is between the bigger parentheses here? It's a functional interface. But what functional interface? It's a consumer. Okay? So the argument to for each is a consumer. If you look at the definition of for each, you'll see that. Let's actually do that very quickly. And hopefully, yes. So you see, it's a consumer. So you're basically wrapping this function inside that, you provide an implementation for consumer and then you pass it here. And if I ask you what is the type of this one, then you say it's comparator, yes. And here I'm using, this is not method referencing, but you see the implementation of this comparator is just calling a method. And every time the implementation of a Lambda is just calling a method, you can replace that by method referencing, right? So you can instead do this. Why you can do that? Because the implementation of the Lambda that you were going to do was just calling a method, and you can make it more concise by doing it this way. I think this is a little bit late in the afternoon, so I'm going to try to wrap up here. Any questions before I wrap up? Oh, I want to show you one more thing, just for your information. The other strength of the streams is parallelism. Parallelism is hard. You cannot achieve parallelism very easily. But the streams, provide, a very easy way of doing things in parallel. So, for example, here in this example I have, let me actually see if this is, yep. So here I have a collection of employees, and the size of the collection is 1 million. So I have 1 million objects inside this. And what I mean to do is, let me see, what am I doing here? So I'm calculating the average salary, basically. I am converting the collection into the stream. Then I'm mapping, because employee, average for employee doesn't make sense. You have to average of what of employee. So I have to convert it from employee to employee salary. So here's a mapping. So employee object comes through the door, the salary goes out the door. So this is how the pipeline works. And then the salaries are going to be averaged. Okay? So this can be a time-consuming process. How can I streamline? Well, using parallel programming, this can be a streamline. So I have a quad-core processor on my machine. So theoretically, I can run 4 threads at the same time, and then divide this collection into 4 different sections. Do the average of each quarter, and then just calculate the average of all 4, right? And then put the results back together. How many people have done multi-threading in Java? Multi-threading in Java is very, very complex, and you have to take care of a whole bunch of things. But, I'm sorry?
Because of the blocking.
There's a whole bunch of issues, synchronization problems, a whole bunch of problems. How can you do it using the streams? It is as simple as this. Instead of calling the stream, you call the dot parallel stream, and you get parallelism. Just like that. As simple as that. The only thing that you have to remember is that if you make your stream a parallel stream, the operations that you perform on the elements of your stream have to be associative. Because if you're not associative, then you get errors in results. Associative means if you combine these two elements, or if first you combine these two, or if first you combine that two, it shouldn't make a difference. Okay? That's it. Any questions? Very good. Thank you all for coming. Yes?
Can you find like the middle value in the string, like using gate method?
The middle value?
Just like an array we can access using an index.
Yeah, remember that a stream is not a random access structure. So it is not going to be easy to find a middle element. I have to think about it. It's not going to be, that is not the best application of the streams. Any other questions? Okay? So thank you very much. I enjoyed it very much, and thanks for coming. Remember that next month we're going to have